So in this video, we're going to go ahead and go over some of the basics of graphing an image in Desmos. And so this was the image that I kind of liked. It's the cartoon image. You can go over that in one of the previous sections that was showing why, how to pick an image. But what I'm picturing when I see this image, and that's the main thing, when you look at the image, you got to think, what kind of functions are we going to use for these different spots? And so if I'm looking right here, I could see that these are going to be lines. So lines are pretty simple. You can also see on the side of his head, that's probably going to be a line there, a line on this side. Those lines, sticking to those lines, those are going to be the easiest things, so you can take care of those pretty quickly. There's a line there, and there's lines up here on the helmet. And then looking at the top of the helmet, I'm picturing either a oval, well, kind of a circle shape. We'll go over that. In the next section, we're going to talk about common functions to use, good functions to use, or we could use a parabola. They kind of have a little bit of a difference, and well, I'm going to start with the parabola, but it may not work. And then down here, this could also be kind of a semicircle or a parabola. This over here could be done with lines, that could be done with lines, or if there's, you can zoom in. If you see a little bit more curvature, you can kind of use parabolas. So honestly, parabolas, right here, a little bit of curvature parabolas probably work fine. Sticking to a lot of parabolas and a lot of lines, that's really what's going to help you a lot in going through this. I'm seeing there's a line there, right there. This could be done with a parabola. So a lot of different things. And then something also to mention before we continue is that you can toggle this image on and off by pressing right there. So once you do a shape in there, if you really want to see if it matches up, you can always, or how your image looks, you can always turn the image off. You don't have to exit and then undo or anything like that. You can just quickly just turn that on and off. So let's just go ahead and start with one of our graphs. So I'm picturing a parabola, and it's centered. We don't need to move it left or right. Let's just move it up to the top here and flip it upside down. So how do we make an upside down parabola? Well, we put negative x squared. And then to move it up, I'm going to add on the outside. And it needs to go up just a little bit more, so maybe 4.1 or 0.05. You can be a little bit picky, 0.06 or 0.07. Right there, that looks pretty good. Now you want it to be wider, so if I put like a 2 or a 5, that makes it a more narrow parabola. And this is where you're learning in this. You're going to be going through some of these things, maybe thinking about why are these things happening, why is it changing the shape of the graph. So we want it to be wider, so obviously let's try 0.1. That's too wide. 0.2, that's, well, it's kind of getting there, 0.5. And I can already see that, hey, you know what, for this, it doesn't quite look like the parabola. That's pretty good there, but it doesn't quite fit the shape as we get around there. Now, something you can do is multiple parabolas, you can cut it off. So let's look at cutting off the domain. I'm going to try a circle though in a little bit, but cutting off the domain, let's go over that. So maybe you like just a piece of this. Well, something you could do is trace the graph like that. And I recommend using a piece of paper. You can trace it right there and write down 0.306 and then trace it as your left bound and maybe write negative 2.97. And I forgot those, but let's go over how to cut this graph. So you use the braces, and I think it was like negative 0.279, and you use less than or equal to x, less than or equal to... I forgot what I said on the other side. Let's just do 0.279. And what you could see is this cuts the domain. Remember, x is horizontal, so we're cutting it horizontally from negative 2.7 or negative 0.279 to positive 0.279. So we're cutting those off as far as the x values on the x-axis are concerned. Can we do this as a vertical cutoff? Yes, you can. Let me show you how to do that. So that's a domain cutoff. So what about a range cutoff? In order to do that, I'm going to put y equals. It needs to have a y value, otherwise it won't accept it. Or I could just show you that. Why don't I just show you that real quick, so in case you run into that issue. So if you're doing this, you want a vertical cutoff, maybe you want everything to be above. Look at the y value in this case. We're going to do a vertical cutoff, 2.784. So let's just say I want everything above 2.784. So what I'm going to do is I'm going to say y is greater than or equal to 2.784. Now the problem is you'll see this has this little indicator saying, hey, I don't like that. So what you need to do is you need to say y equals to define a y in the problem. So you can't restrict it based on y values without the y. The only time you can do that is with the vertical line. X equals like 4. gives a vertical line, and you can restrict the y values without having actually y put into the expression there. But for the other functions, you're going to have to put a y into the expression in order to restrict it. And you can see there, all our y values are above the 2.784. From there, what if you want to change the color? If you don't like that color, you press and hold this. Gives you different styles, and these are your color choices. What if you want some shading? Then you're going to do less than or equal to. It's going to shade it. So shading's a little more difficult. Probably save that till later. Now, once again, I didn't like the way the parabola looks on here, so I'm going to do an oval. So let's start with the circle equation. That's x squared plus y squared equals, let's go with 1, that's the radius, and I need to move it up, so I'm going to put y minus, since it's inside the parentheses, let's go with y minus 2, no, let's go with y minus 3, so that's just moving it up. I might want to move it up just a little bit more. There we are, and you can make the radius greater. We can move it left or right by doing the same thing here. Obviously a plus would go to the left, negative would go to the right, just like over here. Negative went up, plus would go down. Because in the parentheses, it does the opposite of what you think. Now, if you want to make it more of an oval shape, you can put like a 2 here. Or actually, what's kind of funny is you could put a 2 over here, but that's going to make it, you know, more vertical. But if you put a 0.5, it'll also make that change. Over here, adjusting the radius 5 is just going to make it a bigger shape, like 1.2, 1.3. And you can see this is a little better shape. Maybe 0.5 isn't quite what we want. Maybe we want something like, oops, let's go the other way with it, 0.7. Let's go 0.6. Make it a little bit bigger. And then I'm going to move it back down a bit. 0.8, 0.7, 0.6. That's looking pretty good there. Let's make it just a little, change this a little bit. So 5, nope, I wanted to go the other way. 8 was too much, 7 was good shape, 6 was where we're at, so let's do 6, 5, 6, 6, 7, 8. I want to get that shape to it, so let's try 0.7 again. And then I'm going to increase the radius just to make it bigger. And that's pretty good. If I was being extremely picky, like if this was my project, I'd probably continue with this just a little bit more. Move this down just a touch. And right there, I'm going to do a vertical restriction. And my finger's in the way, so I can't read that. Okay, 2.7 or 2.6. So I'm going to do the braces and say that y is greater than or equal to 2.6. Right there is pretty good. We could change the color. And anyways, that's just kind of an introduction to how you're going to graph this.